Now I will discuss a method of finding probability of an event. Suppose I have been given, and this is my sample space, so let's call this omega, and this is my event, say B. I have to find probability of this event B, and suppose I am finding it very difficult to find probability of this event B. So which technique should I use? Now there is a very famous technique used in diplomacy also everywhere, that's the technique of divide and rule. I have to find P of B on this sample space omega, and this sample space omega, suppose it is very difficult for me. So what I can do, I can divide this sample space into different regions. So let me divide it with some different color so that you see it clearly. Okay, let me divide using red color. So what I will do, I will divide my sample space like this, then it may be like this. So suppose effectively what I have done, I have divided my sample space into three parts. This part is A1, this part is A2, this part is A3. So these division of sample space, they are called partition. Now partition is a very technical term, at least when we are dealing with probability. So what are the properties of these partitions? Number one, you can say that these are basically nothing but events. They are subsets. All the AIs, they are subset of omega. Okay. Another thing is that none of the AIs are overlapping. That is, intersection of AI is equal to null set. That is, all the AIs are disjoint. A1 is disjoint with A2, A2 is disjoint with A3. So all the AIs intersection is phi. Suppose you take A1 intersection A2, that will be phi, A1 intersection A3, that will be phi. So all the AIs are disjoint. And third thing is when you take union of all the AIs, you effectively form the whole sample space. So if any sequence of event or any subsets of say sample space, these events, they are called partition if they are having these two properties, that none of them are overlapping, number one. Number two, that all these events A1, A2, A3 collectively they form sample space. So they are called partition. Even if you don't learn this technical term partition, intuitively it is very clear that what I am doing, I am dividing my omega into three parts. Once I have divided my omega into three parts, what I can write, that my set B, this is the set whose probability I have to find. This B set, this event B comprises of this thing, then this thing, and then this thing. So what is this? This is A1 intersection B. You can see this. This portion is A2 intersection B, and the third portion is A3 intersection B. So my set B comprises of three sets: A1 intersection B, union A2 intersection B, union A3 intersection B. Okay. Now all these three sets are disjoint sets. Why? Because A1s are disjoints. So this and this A1 intersection B, A2 intersection B, A3 intersection B, they are disjoint sets. So what is the benefit I am getting by working with disjoint sets? Use axiom number 2 of probability, that since these three are disjoint sets, probability of B will be sum of these three probabilities. Okay. So I had my goal of finding this probability of B. I have broken this task into finding the probability of this event, and this event. So using formula of conditional probability, I can say that probability of B given A1 is equal to probability of A1 intersection B divided by probability of A1. So I can use this formula to find probability of A1 intersection B. So I can write probability of A1 intersection B will be probability of A1 into probability of B given A1. So similarly I can write for A2 also, I can write for A3 also, and using these three formulae I can get my total probability that is probability of B. So whatever I have derived and told you, the exactly same thing that is given by a theorem called theorem of total probability. So let's see that theorem. That theorem says, let A1, A2, An be disjoint events. That's why they are partitioned. Disjoint events that form a partition of the sample space. That is, each possible outcome is included in exactly one of the events A1 to An. Exactly the same thing I have told in set theory notation, that intersection of AIs is 5 and union of AIs is omega. That is, each possible outcome has to lie in one of the AIs, that A1, A2 or A3, and it has to lie in only one of the A1, A2 or A3. Why? Because these A1, A2, A3 are disjoint events. They cannot have a common, or they cannot have any intersection. So when you have A1 to An partition and assume that PAI is greater than 0, then only I can talk about this partition. Then for any event B, we have probability of B is equal to this A1 intersection B plus this thing. So probability of A1 intersection B is probability of A1 into probability of B given A1, and similarly for A1 to An. This total probability theorem I proved in the last slide. So now let's see one question based upon this thing. Okay, this is the exercise. The probability of a student clearing IIT JEE exam is 0.3 if he does self-study, 0.4 if he has done correspondence coaching, and 0.5 if he has done classroom coaching. If 50% of students have done self-study, 25% each have done classroom and correspondence coaching, what is the probability that a randomly selected student will be selected in IIT JEE? Oh, just don't go about these figures. So I don't think that, okay, if you are doing self-study at home, then you have very little probability as compared to those doing classroom. This is just hypothetical question. So let me, these three A1, A2, A3 are my partition. So this is 50%, 25%, 25% consist of the sample space of the whole students, the 5 lakh or 10 lakh students who are preparing for IIT JEE. So let A1 be the event of self-study, A2 be the event of correspondence, this one, and A3 be the event of classroom coaching, and let B be the event of selection. So now using total probability theorem, you see I can write that probability of A1 is given 0.5. Why? Because we have been given, based upon whatever data, that empirical data, that 50% of students are doing self-study, 25% are doing correspondence, and another 25% are doing classroom coaching. So probability of A1 is 0.5, A2 is 0.25, and probability of A3 is 0.25. Now this is probability of B given A1, that is probability of success given that you are doing self-study is 0.3, probability of success given that you are doing correspondence is 0.4, and probability of success given that you are doing classroom is 0.5. So now I am picking a randomly selected student out of those 10 lakh students. So what will be the total, that probability? The probability that I will select a self-study student will be PA1 into PB given A1, and this is the total probability theorem. So you do the calculation and multiplication, you will get that 0.375. So basically what this total probability theorem say, that okay, you have to find event of, say, selection or anything. This is a composite event, this is a compound event. It consists of two steps. First you have to select a student. Now that student may be A1, A2, A3. So what is the probability that I will select a student belonging to group A1? That is 0.5. Now that I have selected a particular group of student who is belonging to a particular group, what is the probability that that student will be selected in IIT given that he belongs to group A1? That is 0.3. So this is 0.5.